In this section, we're going to be talking about what compression and limiting is all about, and we'll see how it affects the dynamic range of an audio signal. All of the Dynamics plugins we'll be using have an effect on what's called the dynamic range of an audio signal. So it's very important for us to understand the basics on what dynamic range is. So for this example, we're going to be using a single snare drum sample. It's really a great instrument that we can use to describe what dynamic range is because it's a very dynamic instrument in nature. So if we play back our sample, you can hear kind of what we're talking about. So we have this section where the stick hits the drum, and this is called a transient. A transient is typically referred to as the loudest part of an audio signal, or the attack. And as the sample gets softer over time, this is called the decay, or the release. And dynamic range is really just the difference between the loudest part of an audio signal and the softest part of an audio signal. We can inspect this further by taking a look at our peak meters that are in our channel settings window. So we'll just click the E to open up our channel settings window. And off to the right here, you'll see that we have our meter. Right below the meter is our peak level. So if we play the sample back again, what we're going to be seeing here in the peak level is the loudest part of this audio signal. So you'll see that the loudest part of the snare drum where the stick hits the drum is reading minus 5.4 dB. Now if we reset our meter by left clicking on it, and we play back the sample where there appears to be no signal, you'll see that we actually have a reading of minus 65.4. So there is audio still going on here even though we don't hear it. The dynamic range is essentially the difference between this lowest value and the highest value. Our highest value was minus 5.4, our lowest value is minus 65.4, and that gives this sample 60 decibels of dynamic range. So now that we know what dynamic range is and what our peak value is, there's actually another measurement that we take for average loudness, and it's referred to as RMS, or root mean square. Now without getting into the mathematics, it's basically just an average of the loudest signal and the softest signal over a given period of time. Now we can't view the RMS value from the channel settings window. Instead, we have to go up into the control room mixer under devices and then control room mixer. And you can see this gives us an expanded meter with a few extra options at the bottom, where we can monitor our peak value and also our RMS value. So if we reset these values and play our sample back, you'll see that these two values are going to be quite different. Our peak value is as what we would suspect at minus 5.4, but now we'll see this RMS value is minus 28.2. And the reason why it's so small is it's taking into consideration our maximum value and our minimum value over a given period of time. It averages those together and gives us what we call an average loudness level, or RMS level. And this will be something useful to know in the next section when we start taking a look at our compressor plugin. So take a break and we'll be right back with compression.